Hello everyone, my name is Anishana and today you're watching Docker web series. As of now, we have successfully completed our 8 topics. If you haven't watched the previous video, then you can click on I button. Today we are going to cover our 9 topic, that is type of volume and how to create it. Just for your information that this PowerPoint document can be downloaded from my GitHub page. I have added the link in this video description. Beside this, subtitle for different languages such as English, French, Russian, and German is available for this video. Before start this topic, it's time to do the recap of our image. To run an application, whether it's Nginx, Node.js, any application, it requires RAM, CPU, and disk. Application demand all these resources from the operating system. Whether this operating system is installed in physical server or a VM. This operating system has library and binary files. Library files are used by application and binary files are used by CPU, just for your information. In this case of container, first we built an image and this image we not only include the application but also application and library files. Hence, this is our image. Further, we can say that our image is not dependent on the hardware. Furthermore, if the application validation checks are okay in the lab environment, then we will not observe any issue in the production. While creating this image, we add some layer on it. We have already discussed this point at the time of Docker image video. If you haven't watched that video, then click on I button or check the description of this video. I have added the link. Let's jump into the volume topic and start from the scratch. In the production environment, first we mount the physical server in the data center or it's a VM. Right after we install the operating system. On the top of operating system, we install the container engine. In our lab, we use Docker engine. Now we can create multiple container with the help of image that we discussed in the previous slide and running some application on these containers. Further, we can start writing on it by creating some file or directory. It add another layer in the container, this layer called writable layer. When we delete the container, it is not possible to recover the data. It means that the data does not persist when the container no longer exists. Please bear in mind that the writable layer is tightly coupled with Docker host, so it will be difficult to remove this layer from the container and save it on some other destination. Docker offers one solution for this problem, that is to store file. One can use host machine file system, which means that when we create a container, we must attach the host file system and after that can write in the host file system. To explain more, in this case, when we are writing inside the container, but actually the data is saving in the host machine file system, it look like a mirroring of data. This is the reason when we delete the container, still we have the files in the host machine file system. This will we will cover in the lab section. In Docker, we have three options for container to store file on the host machine. First is volume, second is bind mount, and the third is tmpfs, temporary file system. Please note that out of these three types, only volume gained the popularity. This is the reason I selected today's topic is volume. Needless to say that I will cover all the three topics. Let's explore the volume then. Data is stored in the Docker host file system, which is managed by Docker. It means Docker isolate the core functionality of the host machine. A new directory will be created within the Docker's storage directory in the host machine. Path would be in Linux varlib docker volumes. Non-Docker process should not modify this part of file system. Docker engine create a volume at the time of container creation or service creation. Volume can be shared between different containers simultaneously. Volume also support the use of volume driver, which allow us to store the data on cloud or remote host. So type of volume. So there are two type of volume. One is name and the second one is anonymous. Name volume is at the time of container creation, we specify the name of the volume. In anonymous, volume name is not mentioned at the time of creation of container. Docker gives a random unique name. Both behave in the same way. It's up to you whether you want to give the name or not. Now the next question would be how to create a volume. The command is docker volume create. When we create a volume, there are some options. First, we need to understand these options so that it will help us while doing the lab. So the command option is docker volume create hyphen hyphen mount, or we can use minus v. So let's explore hyphen hyphen mount first. So the command is docker run minus d hyphen hyphen name whole mount container hyphen hyphen mount source equal to my volume 1 target equal to slash app, and the image we are going to use is nginx colon latest. For named volume, the name of the volume is vol hyphen mount hyphen container 1. For anonymous volume, the field is blank. So command option hyphen hyphen mount as it consists of multiple key values pair. So we can say that. So these are the options available inside the volume mount, right? So let's explore these options first. So the first one is key, the second is value, and the type equal to volume. So if we not mention anything in our command, so by default Docker understand that this is a type equal to volume. So if you want to create a bind mount, then you have to specify type equal to bind mount. It include all option in one field separated by comma. So here source equal to my vol1, or we can use short src equal to my hyphen volume 1. So this is the source here, right? The first part. The second is destination or DST or target. This is the key as the value of path where the file or directory is mounted in the container. So target equal to app, you can use target equal to app or use DST equal to slash app. So slash app directory will be created inside the container. Volume hyphen opt, this key can be specified more than once. So when we use NFS as a mount point, so we can use volume opt hyphen type equal to NFS, and then volume hyphen opt means option device here equal to NFS server IP and then path colon followed by path. The other option is minus V. So the command is hyphen D. Again, I'm giving the name here and minus V instead of hyphen hyphen mount. So my vol one slash app. So let's explore this. So it is more explicit and verbose mode. It has three options separated by colon. As you can see here, that colon is there. All these three fields should be in order. However, in hyphen hyphen mount option, the sequence is not mandatory. The first field is name. The name of the volume should be unique in the host machine. In anonymous, this field is blank. The second option field is path, where the file or directory will be mounted in the container. So slash app will be created and this volume will be mounted inside the container. The third field is permission like RO. So RO reference to read only or read write. So whatever option you are giving here, colon slash ro, colon ro. So if I'm not mentioning this, so by default it will take read only permission. So there is a difference here. You can say here hyphen hyphen mount or V option. So V is hyphen hyphen volume. So it include all the option in one field. It is more explicit and verbose mode. The second difference would be it consists of multiple key values pair separated by comma. It has only three options separated by colon. Order of key isn't mandatory. Key values are understandable. All the three fields should be in order: name, path, and permission. So let's jump into the lab for volume. I have already logged into my machine. First command I would like to execute is to check the container is running or not. So there are some container running. So let me remove all these containers. So I have one command that you are already familiar with that. Now I'm going to create a simple container and then go inside this container. After that, I'm going to create one file. Here I want to show you that after deleting this container, I will not see this file. As you can see here that this file is created. Let me exit from this container. Docker container inspect container one. So inspect is the option that we inspect the container. And if we go up, I'm looking here, mount option is blank here. This container is not mount in the host machine file system. If I delete this container with the help of rm-f, f is forcefully because this container is running. If I'm going to execute the same command that I executed previously with container 1, as you can see here that the ID is different, B64. If I scroll up, we'll see ID is 99FA. It means this container is different and the new container is different, even though the name is same. The name is same because we have already deleted the previous container. If I inspect this container again, so here I can see here that ID is E64. It is different. Okay, so let me log in into this container here. Get file. This file is not exist here because it was created in the previous. It means that data is not persist if the container died. Exit from this container. How to check the volume? The command is docker volume ls. As you can see here that there is no volume created. Now I am going to create one new volume, docker volume create and my vol1. Again execute the same command and now this time you will see, you can see my volume 1. Other good option is inspect. This time docker volume inspect. Now you can see here that where lib docker volume and then my volume. This part I have already covered in my PPT session. So default docker volume path is where lib docker volume. How to delete this volume? It's very simple. Docker volume rm. Now it is deleted. It will give me error if I attach this volume with one container, and if that container is running, it will give me an error. But this time I have not attached any container with this volume. You can check volume ls. Now there is no volume group created. This time I'm going to execute a new command, whole mount container one. This is the name of my container, and here I'm using hyphen hyphen mount, and the source is my volume one is the source. It means if this volume is not created, Docker will create by itself, and the target is slash app. Inside this container, I will see slash app directory. Whatever I'm saving any file or directory, creating any file or directory inside this app, I will see the host machine under this area. Let me execute, and this time please bear in mind this here I'm not going to mention type equal to volume. If I'm not mentioning, Docker will Docker is very intelligent and it's create inside the volume. Let me inspect this container, and if I scroll up here, mount is more information you will see here. Type equal to volume, name is my vol1, source is anything I am retaining. If any file I am creating inside this container, I will see all the files inside this directory, and destination is slash app inside the container. Driver is local, z is mode, z is flag. Tell Docker that the volume content will be shared between container. It means this z means container. We can share this data path with multiple container. Let's go inside this container and cd app ls space ltr. You will see nothing here. Now I'm going to create one new file here called vol container name, and control C. Let me check the file is created. Yes, it is created. Exit from this container and then check docker volume inspect my vol1. Now you will see the mount point is this. If I go inside this mount point and do ls space ltr, I will see this file. And here I'm in my Docker host machine. It means that I can add this file and add the content in this file. Let me do it here. Adding from my host machine. And then if I go inside this, not go and this time I'm not going to inside here. Yes, I can see here adding from host machine file. This line is added inside this container. So this is the beauty of volume. Now I used hyphen hyphen mount command. Now I'm going to create another container, and this time I'm using hyphen v command, and slash is the option that the command will be executing, but in this next line. Let's suppose if my line is greater, if I'm typing the more option, if I reach here and I don't have any space, so I can use slash here. This is the slash I use here. This is the slash I used here. This is the slash I used here. If when I press enter, it will create the new container with vol v option container one, and it will again slash map. And here I'm using my vol1 so that I can show you that this my volume 1 is shared between different containers. And remember, as I said that in -v, we can give three options: name of the volume and destination and read write permission. So here I'm not giving any read write option here. So whatever it is, it will be default. First thing first, option is to inspect this container. It will show you mount configuration. You will see here volume, my volume, and the data is same. Local Z, read write true, propagation dash. So minus V and hyphen mount option are same but having a different syntax. Don't be get confused. Let me go to inside this container and then again app. This time I'm going to create a new file vol v container one. This is a raw file for vol v and control C and I can check here. Perfectly fine. If I do ls space minus ltr, I will see one new file that is volume mount container one. The previous container file is here because it is shared. The directory is shared amongst different container. So I will see all the files. Let me exit from here. Okay, so I can also see the content of this file. Let me do it. So I'm logging inside this mount container and checking the this file. Open this file. Yes, I can open it from this container. It means that I have full read write permission. So now I'm going to delete both the container and then we will create a new container and we'll see if I can see the files or not. Let me do container ls space minus a. I don't have any single container. So let me create a new container and this time I'm going to use volume mount container 2 and the mount option is source my volume 1 and slash app. So I can use anything here, right? So let me modify here 1. If I go inside this app 1, sorry, let me let's check this mount to container and less space L. I can see the both files are available here. Even though I can also do cat one of this file. As you can see here that this is the benefit of volume. After deleting the container, still we have the content available in the Docker host machine. So our next topic is bind mount. In bind mount, the data is stored anywhere in the Docker host machine file system. So path is anywhere except Docker storage part. Non-Docker process can modify this part of the file system. It has limited functionality as compared to volume. This is the reason I said that volume gain more popularity of this reason because of that. Okay. So in bind mount, a file or directory on the host machine is mounted in the container, same as it is for volume. This file or directory is referred by its full path in the host machine. So let's suppose that you have created a file inside where home data volume 1. So that full path you have to mention. It will create file on demand if not already created. If we understand bind mount with the help of this picture, so this diagram is depicting the same information as we have in the volume. However, the main difference is that this file or directory that we are going to mount inside the container, this file or directory is not located inside the Docker storage directory. So it's outside from the Docker storage directory. This is the reason performance is really amazing, but it depends on the host machine file system because it is not managed by volume or Docker because it is not managed by Docker. Thus, Docker CLI command to directly manage this bind mount is not possible. So obviously, Docker CLI command is not used to manage this bind mount because bind mount is created outside the Docker boundaries. So for that reason, we can use system command. Let's jump into the lab for bind mount. I have already logged in into my machine. Let me create one new directory, data-bind. After that, I'm going to create a new container, bmount container one, and here I'm using --mount and the type is bind. This time I'm mentioning type equal to bind and the source is data bind and it will mount the directory /app. Let me hit the enter and this time inspect the bmount container one. So I will see here type equal to bind. Previously it was showing volume. Source is /data bind. So now inspect the mount container to volume mount. This is bind mount. And here you see the type equal to volume and here the type is bind. When I created this container, I didn't mention the type. So it by default, when we do not mention any type, it will treat the volume, not the bind mount. Okay. So let me go inside this container, bind mount container and cd/app lsltr. Let me create a one new file here. So this is my test from container bmount container one. I can check this file. Yes, the file is correctly created and exit from this container. If I do ls bind, so here I do not mention the full path that I did for volume because this path, this directory I created initially in the Docker host machine. I can edit this file also like the volume. This update is done from the host machine. Let me check if the content is updated. Yes, the content is updated and I can check the content inside the container. So this time I'm going to bmount, execute and then cat app file.txt. If I press enter, I can see the newly updated line here. Same thing I can use for, I can go for -v command. Let me create a new container with -v option. And here this time I'm using -v. So /data-bind and separated by semicolon and then /app is the target. As you can see here that this container is created. Docker container execute -it and then bmount b option and then bin bash. And if I go inside this directory, I will see all the files. The previous container created file here. The option I covered -mount and -v is volume like this. Let me exit from this container. Okay, let me create a one new container for container 2 and the bind and the source is temp. This time I'm going to use the source is temp, but source and the target is USR. The container is created, but I'm not able to log in inside this container. Why? Because all the USR is overwritten by temp directory of the host machine. Let me show you Docker container ls space -a. So I will see here the exit. Which one? Bmount container 2. So please bear in mind the target should be a blank directory. Otherwise it will be overwritten here. Let me remove this container as I did purposely to show you all the content. Let's proceed further. So our last option is tmpfs. This option is only available if you are using Docker on Linux OS. tmpfs mount can not be shared between multiple containers like volume and bind mount. In tmpfs, we can create files outside the container writable layers. In this, we are saving the data into the host memory, not in Docker host machine disk like volume and bind mount. It means that when container stop, tmp mount removed and data erased from the memory. Use case would be sharing configuration file from the host machine to container, like DNS configuration through etcresolve.conf file, maybe. So the theory part is very less. So let's move to lab for tmpfs. Let's start the lab for tmps temporary file system. I have already logged in into my VM. The very first command I'm going to check, I'm going to delete all the existing container so that it will not create any problem. Let me show you volume. The volume is already created here. So docker volume rm, and then if I hit tab, it will auto complete. This time I'm going to create one new container with temp container one name and the hyphen mount type tmpfs. This time I'm going to use tmps and the destination is /app. So the container is successfully created. Let me go inside this container and then cd app as usual. ls space ltr. It will not show you any files or directory. Here I'm going to create a one new file. This is the test file in temp container one file. I can see this file. Yes, I can see the content of this file and exit from this container. Docker container ls. So this container is running. As you can see here that it is up and running. If I inspect this container and scroll up, I will in the mount option, I will see here it's temp and the source is nothing. Whatever we are going to create inside this directory, it will be saved in the RAM memory of the host machine, not anywhere else. Now let me check here if I can find this file or not. So let me find this file, hyphen name, and then time container one. I should not see any file here because this file is created, but the content is inside the RAM. What I can do here, I can use the Docker CP option to copy the etcresolve.conf file into temp container one/temp directory here. If I hit the enter, I will see the content of this file, temp resolve.conf. I will see the content of this file from the temp container. When I created the container, I use destination. Let me show you here. Here you can see the destination equal to /app. Okay. Now this time I'm going to use target equal to app. Just for your information that these options are working perfectly fine. Target equal to app. Yes, the container is created here. There is another option that I can use here, that temp size is 500 KB. So yes, the maximum file we can create inside the /app directory is 500 KB. And the last option that we can use in the temp, clear the window, tmps mode. So it's world writable. That's it for the temp count point. Thank you everyone. Please like and subscribe to my channel and press the bell icon to get new updates.